Okay, so this tutorial is going to cover just the very basics of Redshift with the idea of how do I get rid of noise, the grain within a Redshift render. Now, that can be a complicated answer depending on what materials and other things you add to it. So I'm going to try to keep this just as a basic setup without complicated materials that are transparent or have subsurface scatter or any of these kind of things. So just want to look like if I create a light and my shadows look grainy, or I turn on global illumination and it looks grainy, or if I use something like maybe even depth of field or motion blur and it looks grainy, where are the settings to tweak that so that I eliminate the grain? There's there's kind of an experimental kind of auto version of this I haven't really experimented much with, but it would be important to understand actually how to do this on a per object, per light, per setting situation. So that's what we're going to do. So I have this still life scene. I have a camera with my little protection tag, and I've set this up just to be a square composition. I also have my Redshift Renderview, which I found up here, right? Redshift Renderview, and I've docked it within this window. I took that little thumb, that little three-line icon, and drag and dropped it on the same little icon here within the view, and it created a tab for me within this window. Right? I have no materials in the scene, and I'm going to go ahead and just press render, right? And so you can see that I get, not very exciting, right? I do get a render, and it does have some lighting information on this, but I don't have any lights in the scene. And so remember when we were using the physical render, let's turn that on, right? In the options, we turned off the default light. And every 3D program basically has this default light setting. So it's just if you start modeling something and you want to kind of see what it looks like in a little more cleaned up version than what you might have in the editor view, the default light is turned on. So you don't have to add one. But most times, you're going to add a light to the scene. So, but we don't turn this off or on and off here for Redshift. If we turn it back to Redshift, we'll click on Redshift. There are a lot of these tabs we're going to talk about. Mainly, some of these we will not ever talk about. Mainly the basic tab and the GI tab. But if we look at the integration tab, the very last one, the only thing we really need to care about right now is there is that default light option. And I'm going to turn it off. And now when I press render, I just get black, right? Because there's nothing in the scene. Well, I'll explain in a second. So let me turn that off, and let's create a light for the scene. If we go up to Redshift and lights, I'm going to use an area light. Again, all these, you could use a spotlight, whatever, but they have their own different settings. I want to keep it simple with the area light. And if I jump out of that camera view, the area light here is this big panel, right, that created. I'm going to make this 50 by 50, and I'm also going to change it from a rectangle to a disc, right? So it just kind of has a rounded edge to it, just because I'm going to treat it kind of like a spotlight. The other thing is to position it instead of just moving and rotating, I'm just going to put a target. I already created a null object that's at the center of the scene, basically. So I'll go up to Redshift and right-click, animation tag, and say target. And with that selected, I'm going to take the target object and tell the tag, this is what you're supposed to point at. And you can see automatically the light changes its direction. And if I just move it, maybe not make it too steep. And let's jump back into the view there. Let's see what I get. Perfect. Okay. So voila, right? I have a light in the scene. That's good. Let's go ahead and look at the light. We'll keep this open here. We changed the size and its basic shape. We could change its color and that stuff. We're going to talk about that later. But really what I care about in this tutorial is how do I get rid of grain, right? What is happening within the grain in the scene here? So you can see that this looks fine, or pretty good. If I look really close, and you probably wouldn't be able to see this in a screen capture, there's a little bit of noise in there. Maybe there's a little bit more noise here, but it's really not that big a deal. It's certainly problematic here in the shadow, right? And a little bit here on this edge. So I think that's the main thing. The rule is with Redshift is how do you isolate which object is doing what so that you know where the grain's coming from, right? If I put a material on here that is not reflective, and of course this is I didn't even put a Redshift material on here, so Redshift just puts a default one, just a flat clay gray onto the surface. And it's not reflective, and I don't even have global illumination turned on, which we'll talk about in a second. So the grain can only be, and it's in the shadows. Well, what is casting the shadow? The light is casting the shadow, right? Well, it's casting its light, and therefore the objects are casting shadows, but the shadows are based on the light itself, right? So you'll see this within the materials, within the render settings, within the lights, is samples. How many times do we sample to eliminate what this grain is, right? And when it comes to using an area light, the bigger the light, the grainier and more samples you will probably need because the shadow is softer or blurrier. Anytime something's blurry in graphics, you probably need more samples to smooth out those the graininess, right? So I could just say, hey, 32. That gets better. And I'm going to do this as the way that, just kind of these multiplying doubles as I go along, just to see. Right, so it's getting better, getting better. I'll double that again. Almost there. Let's go all the way to 512. All right, so, and sometimes these are hard to see within a screen capture and YouTube with all the compression, but that has just a little bit of grain. It doesn't have to be totally perfect because there is a setting called denoise that we can look at later, but I want to get it basically 90% of the way there, 80 to 90% of the way there. Depending on my scene, the denoise is gonna work fine for me. All right, so this is the main thing to think about is as a per light basis, you can change the number of samples that are needed to eliminate grain that might be happening within the object. Now it's important, as I mentioned, the smaller the object, like let's make this 10 by 10. Right, so obviously this is gonna get darker. I'm gonna turn this up so we can see it. Right, so this shadow is not as blurry. I probably don't need as many samples to get rid of the grain. There's just a little bit there, but I'll leave it at 512 because I'm going to leave it at this. Oops, and let's turn this back down to 0. All right, so when you're figuring out lighting, it's a good idea sometimes to strip away materials and just look at the shadows and what's going on. I don't have a material on here. In a minute, we'll come back, and after I do put materials on, how can I evaluate the lighting again? And we'll look at that. 8 minutes, all right, doing good. The other setting right next to samples is spread. So spread of 1 is if the light were set up like a spotlight, just means that, let's go back to our default, that the light can, I'm trying to think of a good way to kind of show this. That the light can emanate out in this direction, basically like a true 180 degrees, right? In fact, I wish that the spread actually related to that, but a spread of 1 just means that it's totally wide open, right? That the light rays can go out in this direction, as opposed to being focused towards the center. Let's go back to the camera, and let's just make the spread 0.1. And we'll go back to this. Right, so you can see that it is now clamped down, so it's more like a spotlight. In fact, let's do 0.05, make it even smaller. Right, so a very narrow spotlight, but it's Because the light intensity is being focused towards it, it's stronger here on the surface. There's different ways to deal with this, but I'm just going to turn down the intensity. I could also turn on Normalize Intensity. I could have been using that at the beginning if I wanted to. And it's a way of kind of setting, so you don't get as many wild swings between the intensity of the light. So many different settings. We're not even talking about the decay model, inverse square, light fall off. I guess the main point here is the intensity, I think, is pretty self-explanatory. You can just modify either the intensity multiplier or the exposure to deal with the brightness. We do have the spread, like how much of a spotlight are we going to get out of that? It's pretty soft, right? And we can change the samples here to eliminate any grain. So that's part one. Now, the other part of this is that, like if I look at the sphere here, I can't see where the sphere ends and when the shadow picks up over here. And in the real world, light would hit this surface over here or this column behind it, and it would bounce, or it would hit the tip of this box, and they would bounce underneath this, right? We've all done the drawings where you show the highlights and highlight side and shadow edge and shadow core and cast shadow when we do like an intro drawing class, right? Because that's the way light works. It bounces around and it reflects underneath, especially this curved surface. But we're not calculating for that first. So let's go back up to the render settings in Redshift. GI stands for Global Illumination. It's a complicated subject. We can talk about lots of different things with this, but for your part, really, you just want to use brute force. And in fact, I'll just turn that on as the primary engine. You can see that my render has already changed, right? Let's turn that off to compare. I'll let that finish here. All right, and within the render view here, if I hover over this, take a snapshot, put a copy of that image here, right? Cinema 4D just does that automatically. In Redshift, you get to choose which ones you want to hold on to, but you can hold on to a whole bunch. All right, so I'll click out of the view here, and let's turn on brute force. All right, and let's take another snapshot so we can compare these two, right? So totally black underneath there. Let's turn off the render for a second. So global illumination, even just with a primary engine working, and brute force is like calculating all these rays from all these pixels, all these surfaces in the scene, and it starts to look in the grainy version kind of like our physical render that you would get in Cinema 4D. So we'll leave that there. The second part, I guess, the secondary engine, you could put this towards brute force as well to get the secondary bounce. Probably get a little lighter in just a few areas, but really the best setting you're gonna get as far as quality and speed is brute force and the irradiance point cloud. And so what you'll see is the image appears to render the first time. That's the cloud, the irradiance point cloud being calculated, and it uses some of the brute force information, I think is the way that works. So this is gonna give you your best result. But you'll notice we still got, we now have grain in here where we did not have it before, right? We took care of the shadow, right? We changed the samples on that, but now we've got more grain, and it seems to be multiplying, right? It's on lots of different surfaces, and that's because of the global illumination. And if we look at the brute force GI, the number of rays is 16. We can do the same thing we did before, right? So 16 is usually the default you will see throughout. So that definitely looks better, getting rid of that. Also, sorry, I should have mentioned this before. So I'm rendering, this little button here is the bucket rendering. So instead of doing progressive, where it just gets better and better, this simulates the final render, what it would look like with the render settings in that final. So if I press this, this would be like a final render, which is exactly what that bucket render is doing with the interactive renderer. So when I press this here, this says, let's use interactively update any changes that I make, but let's do it in the form that will simulate whatever the render settings are. So back to our number of rays, we'll do 64. Right, already looking cleaner, but still just a little bit of noise in there. Let's do 128. And again, some of these will be slightly different. It's hard to see, but that's pretty close. I might go just one more, like when I get ready for my final render. I would probably test it with the denoiser in here, but I'm not really adding that much render time, and that looks pretty good. Again, just trying to get 90% of the way there. So I look, there's a little bit of speckling going on here. That's totally fine and acceptable to me. Okay, so well, let's talk about, I guess, let's do one more setting, I guess, in here. The other place that you would change and deal with the samples, if we go to the basic tab, we have the samples min, samples max. This is the unified sampler. So this is like the sampler to rule them all. This is the one ring, as it were, within the rendering engine. And with great power comes great responsibility. This says, let's not focus our samples just based on the light. Let's just sample the hell out of everything. And for the most part, you don't want to use this to get rid of issues because it will greatly increase the render time. But for some effects, this is the only one that's going to eliminate the grain. And two of those would be depth of field and motion blur. So, and you might use it sometimes with reflections, can be a little pesky. I'm not even going to go too much more into those. But the unified sampler, and I just mentioned this in case you go looking in tutorials, only use this if you're, I would say, if you're going to use depth of field or motion blur. Of course, we will certainly mess with motion blur while we deal stuff with our characters. So if I did want to with the camera, if I wanted to do something with motion blur, so Cinema 4D is really nice in that if you click on the object, there's something down here called the focus distance. So I go into the scene, if I click on this little arrow, this is like it says, hey, I'm going to select something. And if I just click, I'm going to click about right there, part of the way onto the sphere. Let's do it again. You can see the number. When I click on it, it's setting how far that pixel is away from or that point in space on that object is away from the camera. So that's what I'm focusing on. And within the physical render, I can tell it to have an f-stop. So the smaller the numbers, the more blurring effect you're going to get. I'll just leave it at just a low number there. And then on the camera, I'm going to add a Redshift tag. It's just, this has Cinema 4D stuff talk to the Redshift stuff as far as the render. Within that tab, there's this bokeh, that's what the term referred to, these big blurry like highlights you'd see in a shallow depth of field. Maybe I'll do a separate tutorial about that, but I'm going to turn on override and enable. So it just says, hey, let's use these effects within here. For the most part, it's going to get the distance, and the COC is the circles of confusion. Basically, it's how blurry that stuff looks. You can do this within Redshift if you want and change it, but we'll just start with using the Cinema 4D one. I really can't remember how I built this space, and we'll see. All right, so I've got it set at an aperture of 1, which is a pretty fast aperture, and therefore very shallow depth of field. And you can see the blurring that's happening here. And again, it looks grainy, right? Again, the only place to solve that problem would be in the render settings. So I might just even leave that at 4. I'm going to increase the max samples. There's how many samples do I need in the areas that aren't that troublesome? Maybe I'll turn that to 16. And this one, let's start at 64 maybe. So much better than it was, but still a little blurry. I'll go up to 128. So each time adding a little more render time to this. And as I'm looking at this, it's still a little grainy in various places. I might bump this up. You can see it's definitely getting a little slower as it moves along. But I'm getting this really nice photographic effect, right, where these are slightly out of focus within the scene. Okay, that's about 20 minutes. I'm going to leave it there. Let's recap. Redshift has its own default light. Turn it off. I guess, if you're adding, the nice thing here is if you're adding just Redshift lights, once I add one light, the default light won't come on. If you're using different types of illumination types, it's there. I just turned it off so we can start with just total darkness on the surface. I haven't really used Redshift material. Maybe that's the last thing I will show here is let's just create a material, Redshift. I'm going to give it some roughness and it's blurry. And I'll just drag it up here on the objects. And this happens sometimes. I'm on Mac, so it's a little bit of a beta. There we go. Sometimes what I have to do is pop out of the viewer and look at view and then jump back to it. Okay, so there's a little bit of grain in here, probably related to the reflections, the blurriness of those reflections. But if the reflections are throwing me off, a nice little tool within here, within Redshift, is the regular mode, which that's what it shows when it's kind of an empty circle. If I click on clay, it will render it with that default material, right? And this is a good, especially if I have transparent objects and I'm trying to figure out where's all the grain coming? Is it materials? Is it because of the global illumination, right? This is a way to kind of diagnose the lighting information without the materials throwing you off. I can turn it back to the regular. There's also a samples mode. So this is showing me where all the sample energy is going into the scene. And this is why Redshift's so fast, because it's good at creating this map of importance. Right? Where do I need the samples and where do I not need that? This is well past the point of this tutorial, but it does show you what we've been talking about, right? The whole entire setup. So don't forget that clay. That's the most important part as you're diagnosing lighting and the need for samples and what's going on. And then you can go back to your regular setting. Again, love the Redshift render, uber quick, nice results. And even though you have to do a little bit of fussing to get all the samples right, I like the way it's laid out. It's, I guess until we get into the reflections, it's really pretty systematic about where you can think about where these samples are and how to diagnose that and correct the issue. So, all right, basics of Redshift and samples and noise. Happy rendering.